Let's look at a series of graphs to figure out what type of leading coefficient we have, whether it's positive or negative, and what type of power we have. Is it positive? Is it negative? Is it even, or is it odd? So as we run through each type of graph here, we're going to start with the power. We're going to look for the power first. Is it even? Is it odd? Is it positive? Is it negative? And then we want to keep in mind if the graph is in quadrant 1, the first quadrant, K has to be positive. That coefficient K is positive, and we'll label it here if you don't know the quadrants. 1, 2, 3, and 4. If the graph is in quadrant 1, it has a positive coefficient. All right, so let's look down through these graphs. So starting with graph 1, we're going to think about the power here. So the power must be even, first of all, because we are symmetric about the y-axis. I can fold it along this y-axis and they would overlap. So definitely even for the power. And now we want to figure out, is it positive or is it negative? Well, since there's this vertical asymptote, that means we have x in the denominator and we can't divide by 0. So anytime there's this vertical asymptote, that means that you have a negative power, putting it in the denominator. So the power is even and it is negative. And then the value for K. Well, you want to think, is the graph in the first quadrant? It's not. So K must be negative. So you have a negative coefficient with a negative power, that is even. If we move down to graph 2, we want to think, first of all, what kind of power do we have? Is it even or odd? Well, if it's symmetric about the y-axis, if you can flip it on that y-axis and it would fold over onto itself, you have y-axis symmetry. That tells you you have an even power. If you have a vertical asymptote, that would tell you you have a negative power. This one doesn't have a vertical asymptote. Nothing's going to make me divide by 0 here because we have a positive power. And then we want to think about the coefficient. Is the graph in the first quadrant? No. So the coefficient must be negative. Let's jump over here to graph 5. Again, we have symmetry about the y-axis where I could fold this over the y-axis and it would overlap. So it's definitely even. Only even powers can fold along that y-axis. So we have an even power. Is it positive or is it negative? Well, does it have a vertical asymptote? There's no vertical asymptote. You can plug in 0 and you get the point 0. So it is a positive power. Nothing makes you divide by 0, so there's no negative power putting it in the denominator and making you divide by 0. So we have even, positive power, and then we want to think about the coefficient K. Is the graph in the first quadrant at all? Yes, it is. So the coefficient must be positive. Looking down at graph number 6 here, we have ends ending opposite directions. We are down, up for our end behavior. Those opposite ends mean that we are symmetric about the origin here. This is an odd power. Odd powers and opposite arrows. So one's down and the other is up. It's an odd power. Is it positive or negative? It's a positive power because there's no vertical asymptote here. Like with this one here, it makes you divide by 0. You can plug in 0 here. The y value is 0. You can't plug in 0 to a negative power though, because it makes you divide by 0. So it's an odd positive power, and we're going to think about the coefficient. If we have the graph in the first quadrant at all, the coefficient must be positive. If it's not in the first quadrant at all, that's how you know the coefficient is negative. All right. Looking at some more graphs following these rules, we're going to first figure out what's happening with the power first. So I'm going to look over at this graph number 3. The power must be odd because we have opposite end behavior. We have up and then down. It's odd. And is it positive or negative? Well, you can plug in 0 to it and you get 0, so it must be a positive power. So then we just want to think about the coefficient out front. Is the graph in the first quadrant? No, there's no graph in the first quadrant, which means you have a negative coefficient. We got flipped from a positive coefficient. Over here was down, up. And this got flipped about the x-axis. It is up, down, because we have a negative coefficient. If we look down at graph number 4, we are back to being symmetric about the y-axis. I can fold it along the y-axis and it would line up. So we must have an even power. But we can't plug in 0. Makes us divide by 0, so we get that vertical asymptote that we're going to talk more about. So this must be a negative power. And we want to think about the coefficient. Do we have any graph in the first quadrant? We do. So the coefficient must be positive out front. Moving over to graph number 7 here, we have symmetry about the origin. You'd have to flip it on both the x and y axis. So it's not symmetric about the y axis where we just flip it over and it's right there. We'd have to flip it along the x axis as well. So this is symmetry about the origin, which tells me the power is odd. They have opposite placement. One's up, the other's down, whereas even placement, it would be up, up. They're both above the x-axis. So this is odd because we have opposite placement. It's not symmetric about the y-axis. And we want to think, is it a positive or negative power? Well, there is no place where we can plug in 0. We get a vertical asymptote there, which tells me it was a negative power. If you can't plug in 0, it's a negative power. And then we want to think about the coefficient. Is the graph in the first quadrant? Yes, there is. So you have to have a positive coefficient to be in the first quadrant. We have down on one side, up on the other. So we have a positive coefficient. Our last graph, we want to think, is the power even or odd? Well, we have opposite placement. One's up, the other's down. You can't just flip it right along that y-axis. So it is definitely not an even power. It's odd. We're symmetric about the origin. And we can't plug in 0 to it. There's a vertical asymptote there. There's no y value. So it must be a negative power. And the coefficient out front, is there any graph in the first quadrant? No. So the coefficient must be negative. The difference between graph 7 and graph A is the negative coefficient. We went from down, up, and flipped to be up, down because of the negative coefficient out front. And there's a bunch of graphs being able to explore the type of power, whether odd or even, and whether they're positive or negative powers. Negative powers all have that vertical asymptote versus positive powers do not. And then positive coefficient is when the graph is in the first quadrant. Negative coefficient is when the graph is not in the first quadrant at all.